Hi, my name is Max, and I'm here to summarize my master thesis for you in this video. My thesis was about creating a VR experience that helps people understand construction details with virtual reality. If you've ever tried to understand one, you will know that construction details are complicated. Let's look at this one for example. Here you see 24 building elements that, in a complex interplay, constitute a basement wall. And this is how such a basement wall is usually shown to first-year architecture students, and they are supposed to understand how such a wall works or how it is built. There are two problems with this. Firstly, 2D drawings are abstractions and they can never depict the whole reality of a construction detail. Secondly, for most students, memorizing what they see on a 2D drawing is not a very suitable way for learning how a basement wall is actually constructed. Let's look at some theories about how we learn. Traditionally, we learn by memorizing things from a textbook, which is also the way we usually learn about construction details. That is definitely not the best way to learn what the detail actually looks like in reality or how you actually build it. A better way would be something called experiential learning, which is basically learning from experience. We experience something, then we gain knowledge from processing and interpreting what we have just experienced. And another good way of learning is by solving a problem. Confronted with the problem, we identify what knowledge we need in order to solve it, and then we proceed to acquire that knowledge to solve the problem. The latter two ways of learning are much more fun, and unsurprisingly, the knowledge we acquire through them is much deeper and more long-lasting. So, the good news is, with VR technology, we have a way to learn these construction details in an experiential or problem-based way. With the advancement of technology, 3D models have become a common way of communicating architecture today. Recently, the advancements in virtual reality hardware have made VR devices affordable enough so that they can be discussed as a viable alternative for teaching construction details. And that's exactly why I created such a prototype of a VR experience for learning. The most important aspects when designing the VR experience were the following. It should be immersive to engage the user, and it should be interactive to enable experiential and problem-based learning. The VR experience should leverage the possibility to integrate several information layers. And finally, it should be as simple and intuitive as possible so that the user doesn't get confused when using it. Great, so let's take a look at what the resulting VR experience looks like. To make it as easy as possible for the user to dive into the experience, I created a tutorial that quickly introduces the user to the various functionalities of the experience. In case you forget how to access certain functionalities, you can look down at the controllers where you will find floating labels that explain which button does what. As for the information layers, I created floating labels that shortly explain each building element when it is shown in the construction sequence. You can also highlight certain groups of elements, for example those responsible for drainage, to better understand the connections between different objects. Finally, we can interact with the model directly. The integral element of the experience is the ability to assemble or disassemble the model element by element. This shows you the sequence in which the wall should be assembled in reality to help you understand the construction process and its implications. This is an example of experiential learning. Another important part of the VR experience, which implements a problem-based learning approach, is the quiz mode. When you're ready, you can start the quiz mode, and you're then asked to solve 5 questions by selecting elements from the model or by answering single or multiple choice questions. In order to verify whether my VR experience actually helps with learning, I conducted a little study with 41 participants. Some of them had a background in architecture, engineering or construction, while others had never seen a construction detail before. I randomly divided them into 2 groups. A test group that I asked to learn the detail with my VR experience, and a control group that should learn the detail with a classic 2D drawing. When they were done learning with their respective media, I asked them to fill out a questionnaire that tested their knowledge. Then the control group was allowed to test the VR experience as well. The last step for both groups was a questionnaire that asked about their background, their pre-existing knowledge, and their opinions about the VR for teaching in architecture. Based on how the participants rated their pre-existing knowledge, they received a pre-existing knowledge score. I compared that score to their performance on the exam in order to measure the learning success. It turned out that people without a professional background in architecture, engineering, and construction performed significantly better on the test if they had learned with the VR experience instead of the 2D drawing. For those with a professional background, however, you can see here that I could not measure a significant difference between learning with the VR or learning with the 2D drawing. You can only see that the variety in the test group's results is smaller than for the control group. In conclusion, I can say that the VR experience definitely helped those people who had never seen a construction detail before. All participants reported that learning with the VR was more fun and more engaging than with the traditional methods. That is great, since engagement and motivation are among the most important aspects of learning. A flaw in this study was that I let the participants rate their own pre-existing knowledge instead of measuring it in a pre-test. As you can see here, the participants with the professional background rated themselves very similarly in pre-existing knowledge, but their performance on the exam is very varied. Another problem lies in the sampling for the study. Most of the participants were people that I know, so the sample is very biased and it's mostly university students or recent graduates. Despite these limitations, I could show that the acceptance for VR in education is high and that VR engages the learners much more than a traditional way of learning. The fact that VR allows a reasonably realistic depiction of a construction detail shows that VR is more suitable for teaching construction details than a 2D drawing. It allows for experiential and problem-based learning and, last but not least, allows for several information layers to be added onto the detail. VR will certainly play a big role in the future of architecture education, and also of architecture in general. So, while the adoption of new technologies is not always an easy and straightforward process, it's important that architecture schools don't miss this opportunity now to implement simple VR experiences into their curricula. It improves the learning for students while also preparing them for the technologies that are coming at us in the coming years. So, I hope you learned something new today. Thank you for watching my video, and if you have any questions, feel free to get in touch with me.